Welcome to all. I am going to present about the factor affecting the human condition that describe the factors that affect the human comfort. The comfort of the human body depends primarily on three factors: the dry bulb temperature, relative humidity, and air motion. The temperature of the environment is the single most important index of comfort. Most people feel comfortable when the environment temperature is between 22 and 27 degrees Celsius. Let's say 72 and 80 Fahrenheit. The relative humidity also has a considerable effect on comfort since it affects the amount of heat a body can dissipate through evaporation. Relative humidity is a measure of air's ability to absorb more moisture. High relative humidity slows down heat rejection by evaporation, and low relative humidity speeds it up. Most people prefer a relative humidity of 40 to 60%. Air motion also play an important role in human comfort. It removes the warm, moist air that builds up around the body and replaces it with fresh air. Therefore, air motion improves heat rejection by both convection and evaporation. Air motion should be strong enough to remove heat and moisture from the vicinity of the body, but gentle enough to be unnoticed. Most people feel comfortable at an airspeed of about 15 meter per minute. Very high speed air motion causes discomfort instead of comfort. In this problem, I'm going to determine the specific humidity, the relative humidity, and dry bulb temperature and volume flow rate of the mixture. The saturated air leaving the cooling section of an air conditioning system at 14 degrees Celsius at the rate of 50 meter cube per minute is mixed adiabatically with the outside air at 32 degrees Celsius and 60% rehumidification at the rate of 20 meter cube per minute, assuming that the mixing process occurs at a pressure of 1 atmosphere. Here, the properties of each inlet stream determined from the psychometric chart. So, according this temperature and enthalpy value, we can able to find out the H1, H2 value and omega 1, omega 2 value and V1, V2 value as well. In the figure, the right hand side, the 1 and 2 air entry will mixing into the mixing chamber, and then it will be leaving at portion 3. This is the outlet of the air exit port. The right hand side you can see the psychometric chart where we can find out the record values like H1, H2, V1, V2, omega 1 and omega 2 value as well. The mass flow rates of dry air in each stream are at initial condition V1 divided by nu1 is equal to 50 meter cube per minute divided by 0.826 meter square per kilogram of dry air, and the mass flow rate of dry air at stage 2 V2 by nu2 is equal to 20 meter cube per minute divided by 0.889 meter cube per kilogram of dry air. From the mass balance of dry air, we can calculate the mass flow rate of dry air at 3 is equal to MA1 plus MA2. The specific humidity and the enthalpy of the mixture can be determined from the mass flow rate of air at 1 and mass flow air dry air at 2 is equal to omega 2 minus omega 3 divided by omega 3 minus omega 1. Also, it will be related to the enthalpy like H2 minus H3 divided by H3 minus H1. From that we can calculate the H3 value. These two properties fix the state of the mixture. Other properties of the mixture are determined from the psychometric chart so that the volume flow rate of the mixture will be obtained in terms of V3 is equal to M mass flow rate of air dry air at 3 and small v 3 will provide the volume flow rate of the mixture. This is another one problem. Here we can calculate the specific humidity of air, relative humidity of air, vapor density in air, dew point temperature and the enthalpy of mixture per kilogram of dry air. The specific humidity, the dry bulb temperature condition is 35 degree Celsius, wet bulb temperature is 25 degree Celsius, and also the atmospheric pressure condition is 1.0132 bar. The PV is equal to PVE WP minus PT minus PVE WP TDP minus TWP. dP is nothing but dry bulb temperature, WP is nothing but wet bulb temperature, divided by 1527.4 minus 1.3 wet bulb temperature. Specific humidity is also calculated. W is equal to 0.622 PV divided by PT minus PV. The relative humidity pi is equal to PV divided by PV. Vapor density is equal to PV is equal to mass flow rate of small v and divided by volume small v multiply with RV and TV is equal to rho v RV TV. The dew point temperature is also known value. So from that we can calculate enthalpy of mixture per kilogram of dry air H. H is equal to Cp T dP plus WH vapor. Thanks for watching this video. Within this I will conclude this presentation. This continuation will become that last part.